Okay, our next order of business in section 6.2 is to be able to evaluate functions of other angles besides just quadrantal angles. So some things you want to remember here. First of all, recall that we need to know our trig ratios. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Remember your reciprocals. Sine is the reciprocal of cosecant, cosine is the reciprocal of secant, tangent is a reciprocal of cotangent, and then this isn't a reciprocal, but also remember that tangent is sine over cosine. It's y over x. Okay. One last thing, you're going to be given radians and degree measures. So remember, 30 degrees is the same as pi over 6. It's 180 divided by 6. 45 is pi over 4. 180 divided by 4. And so on. 60 is pi over 3. 90 pi over 2. And so on. It's important that you can quickly make those conversions and actually even identify them by sight. Okay, last thing is from geometry. We have two special triangles. We have a 45-45-90 and a 30-60-90 that I have circled right here now. The 45-45-90 is an isosceles triangle. The legs of the triangle are the same. Now it doesn't mean they're always both 1, but it means they have a 1-to-1 ratio. They're the same. So we can think of them as both being 1 unit long. If you look at the hypotenuse then, the hypotenuse would be the square root of 2. If you ever forget that, it's easy to remember the legs are the same because it's isosceles. But if you ever have to find that, just do Pythagorean theorem. 1 squared plus 1 squared equals c squared. You can figure it out. The 30-60-90 is a little more difficult to remember. The smallest angle is 30. Across from that smallest angle should be the smallest side, which is 1. 60 is the bigger of the two acute angles, so it has a bigger value of square root of 3. Square root of 3 is around 1.7-ish, which is certainly bigger than 1. And then the hypotenuse is 2. Okay, so you need to know these things as we go to try to do the problems on the next page. Okay, so on your first page of 6.2 notes, it looks like this. It says, given that a point xy is a point on the unit circle that corresponds to an angle, t, find exact values of all 6 trig functions. Well, this first point is 3/5, 4/5. The second point is -3/4 radical 7/4, and the third point is -1/2 negative radical 3/2. You're going to get problems like this in your homework also. My suggestion is that instead of doing these problems all separately and writing down all 6 trig functions for every one, just take these problems and kind of make a table and number them. Here's problem number 1, problem number 2, problem number 3, so you don't have to keep writing this sine x, cosine x, tangent x down every single time. Okay? Now, there's another mistake I made in my units here. I said the angle is called t, so these should all say sine of t, cosine of t, so that's my mistake. I apologize for that. I'll just kind of write over these, and you can as well. So what's the sine of t? Well, because this point is on the unit circle, you've got to read the directions carefully. Remember, if the point's on the unit circle, then the sine of an angle is just going to be the y value of that point. So I can say this is simply 4/5. Cosine would be the x value. That would be 3/5. Now from that, you should be able to find everything else. Tangent is going to be sine over cosine, or y over x. Well, what's 4/5 over 3/5? Well, when you take 4/5 over 3/5, you're dividing fractions. That's just like multiplying by the reciprocal. Those denominators are just going to cancel. 4/5 times 5/3, they're gone. So you can just divide the numerators, and the tangent would be 4/3. Now the rest of them, look how I ordered them. I put cosecant first because that's the reciprocal of sine. Then I put secant because that's the reciprocal of cosine. Then I put cotangent because it's the reciprocal of tangent. If you get used to ordering them that way, you'll be more likely to remember which are the reciprocals. So if sine is 4/5, cosecant will be 5/4. If cosine is 3/5, secant will be 5/3. And if tangent is 4/3, 4/3, cotangent will be 3/4. And we can do that same thing for all 3. So this one, sine is the y value, radical 7/4. Cosine is the x value, -3/4. Tangent would be sine over cosine, so negative radical 7/3. Notice I didn't put radical 7 over -3. you never leave a negative in the denominator. A positive divided by a negative is a negative. The answer is either negative or positive. Please don't put the negative in the denominator. It's just silly. Now cosecant is going to be the reciprocal of sine, so that would be 4 over the square root of 7. Now your book may rationalize this denominator and get 4 radical 7 over 7. Not concerned about that. You're fine leaving it that way. Secant is reciprocal of cosine, so that would be negative 4/3. And then the reciprocal of tangent would be negative 3 over the square root of 7. So you can try this last one if you'd like. See if you can fill in the last row. I will wait, and then I will give you the answer in about 5 seconds. So pause the video, fill in the 5 slots, and then when you turn it back on, the answer will come up. Okay, we're back. I have filled in the 5 answers. Compare those to what you have. Hopefully you agree and got the same thing. Okay, on to the next page. Now, find each exact value. The tangent of 45 plus sine of 30. Well, these are both special angles. 45 degrees and 30 degrees are both special angles. So to find the tangent of 45, here's what we want to do. We want to draw a 45 degree. Actually, we can do this on top. If I draw, let me actually cheat here. I'll get my little triangle tool here. I'm going to draw a little 45, 45, 90 triangle on there, and a little 30, 60, 90 on here, just so that we have this to use as a reference. So let's say here's my 45, 45, 90. That's 1, 1 radical 2. You need to be able to reproduce this triangle on command. Okay? And then the 30, 60, 90, make sure the 30 is the smallest angle. Then your 60 degrees. And the smallest leg is 1. The large leg is radical 3. The hypotenuse is 2. Okay? So if I want the tangent of 45 degrees, I go over to a 45 degree angle. So let me get a different color here. Let's go, how about blue? You notice here's a 45 degree angle, and tangent is opposite over adjacent. So go from the opposite side of 45 over the adjacent side. That's 1 over 1, which is 1. Plus the sine of 30. 30 degrees, sine is opposite over hypotenuse. So from 30 degrees, go opposite, which is 1, over hypotenuse, which is 2. So the sine of 30 would be 1/2. You add these, you'll get 1 1/2 or 3/2. Either one of those answers would be fine. Now look at this one. Pi over 2. Well, what the heck is that? Well, pi is 180. 180 divided by 2 is 90 degrees. Remember that? So it might be helpful for you to also draw a little unit circle where the unit circle would cross. Because for quadrantal angles, we want to be able to quickly know where it crosses each axis. So this axis, it would cross at 1, 0. Up 1 is 0, 1. The negative x-axis is negative 1, 0. And the negative y-axis would be 0, negative 1. So this says 3 times the sine of pi over 2. Well, pi over 2 would terminate right here, crossing the unit circle at 0, 1. So sine is the y value. So the sine of pi over 2 will be 1 minus secant pi over 3. Pi over 3, that's 180 over 3. That's 60 degrees. So from 60, secant is a reciprocal of cosine. So since cosine is adjacent over hypotenuse, then secant would be hypotenuse over adjacent. So from 60 degrees, hypotenuse 2 over the adjacent 1. So that would be 2. So I get 3 minus 2, which gives me a value of 1. Okay? You can, remember, you can always rewind this stuff if you want to listen to the rationale over again, okay? Next one, cosecant of 60. So go to 60 degrees. Cosecant is a reciprocal of sine. So instead of going opposite over hypotenuse, go hypotenuse over opposite. So hypotenuse 2 over the opposite radical 3. So that would be 2 over the square root of 3. And then tangent of 45, we found that in the first problem. Tangent of 45 was 1. Well, that ain't going to change. It's still 1. Opposite over adjacent. Multiplying these, I get 2 over the square root of 3. Again, you can rationalize that if you want to, but I don't need you to. Last one, 2 times the cosine of pi over 6. Pi over 6, that's 180 over 6, that's 30 degrees. So go to 30 degrees, cosine is adjacent over hypotenuse, which is radical 3 over 2, plus the cotangent of that same angle. Cotangent is reciprocal of tangent. So instead of opposite over adjacent, it will be adjacent over opposite, radical 3 over 1, or radical 3. Now, when I multiply these two together, the 2's cancel. I've got radical 3 plus radical 3, which is 2 radical 3. And I'm done with this page. One last page. I'm not going to do all these because I only got 15 minutes and I got about 4 minutes of that left. So it says a point on the terminal side of theta is given. Find exact values of all 6 trig functions. Well, once again, I don't feel like writing sine, cosine, tangent, cosecant, secant, cotangent down every time. So I'm going to do these separate problems all on a table. So now this time, a point on the terminal side of theta is given. Notice it's not a point on the unit circle. So don't say sine is 5 or sine is 12 and cosine is 5. That's impossible. Sine is opposite over hypotenuse. The opposite is always smaller than the hypotenuse. There's no way you can get a sine value that's bigger than 1. Okay? So how do I find sine then? Well, what we're going to do is we are going to, let me draw it this way. 512, that point lies on the terminal side of an angle. So 512 is 5 to the right and 12 up. Let's say this is my point 512 right here. Well, it says the terminal side of the angle goes through this point. If you make a triangle by coming from this point down, make a perpendicular always to the x-axis, and close it off, we know that this distance right here is 5, and the distance upward is 12. Well, if I just do a quick Pythagorean theorem, I can find the hypotenuse. 5 squared plus 12 squared equals c squared. That would be 25 and 144, which is 169. You can check my math if you want to later. But the square root of 169 is going to be 13. So c is going to be 13. So that's my hypotenuse. So if I want to find all these trig functions, just use this triangle. Here's my angle theta that they're talking about. The sine of x would be from this reference angle, will be opposite over hypotenuse, or 12/13. Cosine will be adjacent over hypotenuse, which is 5/13. The rest of them you can use a triangle, or you can use the relationships between the trig functions like we did before. Tangent is sine over cosine, so that would be 12/5, and then just take the reciprocal of each. So cosecant is 13/12, secant is 13/5, cotangent is 5/12. Let's try this one. Now the difference here is negative 3/8. That's 3 to the left and 8 up. That would be somewhere around there. So here's the point, negative 3/8. The terminal side of the angle goes through that point. From this point, come down always to the x-axis. So this value is negative 3, and this value is 8. If I do the Pythagorean theorem, we can find the hypotenuse. Negative 3 squared plus 8 squared equals c squared. And make sure the negative is squared, not just... Sorry, I had to pause there because the bell was going to ring. So this gives me 9 plus 64, which is 73. And then I take the square root of 73, which is not a nice number. So we'll call it just the square root of 73. Hold on, I got to pause again. Alright, so if I finish this up real quick, sine will be opposite over hypotenuse, so 8 over the square root of 73. Cosine is adjacent over hypotenuse, so negative 3 over the square root of 73. Then tangent is sine over cosine, so negative 8/3. And then just take your reciprocals again. Radical 73 over 8, negative radical 73 over 3, and last one is negative 3/8. This should allow you to do the next set of problems in section 6.3. Good luck. I'm sorry, in section 6.2. Good luck.